Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh, everybody. Today, our subject is computer networks. Over this session, we're going to go over the definition of computer networks. Why do we need computer networks? What are different types of networks? And the devices that's used to build communication or building networks, and what we call it communication devices, different types of transmission media, and advantages and disadvantages of using computer networks. Since we are in the field of medicine, definitely the first questions could pop up is saying that why do I need to study computer networks? In fact, computer networks is involved in our daily life. For example, if we say that Internet of Things that is very commonly used nowadays, it is actually connecting different medical devices together, and those medical devices connected together for the purpose of collecting data and sending this data to a cloud or to the device we're storing the data, so the healthcare provider can access this data and make their decision. So the internet basically, which is the internet is part of the networks or one type of networks, enables care providers to gain rapid access to information that can be aid in diagnosis of health conditions or the development of suitable treatment plans. This also can make patient records, test results, and practice guidelines accessible from the examination room. So the moment we have done examination or we have test results, immediately this data will be available to the healthcare provider as well to the patient themselves. It can also allow care provider to consult with each other since this data is available, so we can consult each other on that case based on the shared information. And this data can be done, or the sharing of information on the consultation can be done electronically to discuss treatment plans or operative procedures. At the same time, the internet supports a shift toward more patient-centered care. Our main focus is the patient. So by using the internet or Internet of Things, definitely that is, as you can see, it is shifting toward patient-centered care, enabling consumers to gather health-related information themselves, to communicate with care providers. Since I have access to my data, so I can call specialists, whether locally or internationally, different countries, and can ask them about my condition based on the diagnosis and the test results that I do have. And this data information are collected from the devices. Also, the rapid increase of healthcare specific Internet of Things products opens an immense opportunities, and the huge amount of data generated by these connected devices hold the potential to transform healthcare. Yani the form of the healthcare in the future can be changed based on the Internet of Things and the internet which is widely used. Somebody might say, why we are talking about this now? Actually, this is an introduction to a later on subject that you might see. So this Internet of Things that you are seeing right now in here in this picture, actually those are different devices connected to each other, and those devices collecting data about the patient, and these data are collected so later on a specialist can look at it and make make up their decision. So Internet of Things has 4 steps architecture that basically stages in the process. First of all, the first process is consists of deployment of interconnected devices that include sensors, monitors, detectors, cameras, and so forth. These devices collect the data. Then after collecting the data, this received data from sensors and other devices are in the analog form. So we have to transform the analog form into digital form. That's called digitizing. After converting data, then we start processing the data. So this digitized data and digitized and aggregated data uh, can be moved to the data center or the cloud. Step number 4 is uh, data is managed and analyzed at the required level. So advanced analytics applied to this data bring actionable business insight for effective decision making. So the healthcare provider can make up their decision based on these collected data. So all what I said right now, you're going to see it later on when we will talk about Internet of Things in the field of medicine. So this is just an introduction. Why do we need networks? Step number 3, or next slide, is talking about what is computer networks. The computer network basically is a collection of computers such as your PC, your laptop, your smartphone, the servers, and the communication hardware all together connected to one another through a transmission media. This transmission media could be wired or could be wireless transmission media for the purpose of sharing data and resources. Computers are connected to each other, as we said, by either wired or wireless transmission media. In this example, we have wire. In this second example, there is wireless communication media or transmission media. Now, since we talk about digital communication, that means we have to send data from one part to another part. There is a receiving data or receiving device, and in between there is communication channel. So digital communication means a process in which 2 or more computers or devices transfer data, instruction, or information. Therefore, we need sending device, we need receiving device, and in between there is a communication channel that will send the data and receive the data through. Computer networks classification. Computer networks can be classified in different or 3 different types. First type is called geographical span. What do you mean by geographical span? Is how the devices are spread over the physical geographical area. Second is network resource access, is how the parties can access the data. What kind of privileges do they have when they are accessing the shared data or shared resources? Third one is the topology, is the physical arrangement of the communication devices look like, or the architecture of that. Let's talk a little bit into details in this. When we talk about geographical span, we mean in here networks are distinguished based on their geographical span, whether they are in a small physical area or large geographical area. A network can be as small as distance between your mobile phone and your Bluetooth on the Bluetooth headphone, and as large as the internet itself, covering the whole geographical world. So that what we mean by geographical span. Is it small distance or it is large distance? So the smallest network or the smallest geographical span network is called the PAN, or what we stands for Personal Area Network. It is the smallest network which is very personal to a user and handles the instruction of computer devices surrounding a single user. So we have a user here and another user here, and they can transfer data between those two different devices, or your Bluetooth headphone and your smartphone. This is also a network, and you can use the Bluetooth to send and receive data through. The personal area network connectivity range up to 10 meters. So after, if the distance between the sending and receiving device is more than 10 meters, you might start having problem. So the perfect or the standard distance between the sending and receiving device usually is 10 meters. Example of device used in PAN may include wireless computer keyboard, wireless printer connection, wireless mouse, Bluetooth enabled headphone, wireless printer, and infrared enabled devices such as the remote control. So this is an example of that. Example of the PAN, the network between your cell phone and Bluetooth headphone. Also, the network between your TV and the remote control is a good example of the personal area network. Second example of, or second type of geographical span network, what we call it local area network. So with the local area network, so the connected devices are located in one room or in one building, such as your home network or your lab at school network, where devices are connected to each other within short physical distance between the devices. So the local area network could be a wired local area network or could be wireless area network. A wireless area network means that the connection or the transmission media between the connecting devices, the connected devices are wireless. So a network that connects computer and devices in a limited geographical area, such as home, school, computer, laboratory, office building, and so forth. Also, if there's two close buildings to each other, also we still can call it local area network. If it is using wireless connection, then we call it WLAN, and that means no physical wiring between the connected devices. Third one is MAN, or Metropolitan Area Network, connects local area networks or wireless area network in a metropolitan area such as a city. So we have different types of local area networks. We connect those different local area networks together to form what we call it the MAN, or Metropolitan Area Network. Next one is Wide Area Network, or WAN, is a network that covers a large geographical area such as multiple cities, country, or the World Wide Web, or example of that is the internet is an example of the WAN. As you see, the internet, it covers the whole world. So again, we're still in the geographical span type of network. Uh, interconnects or internetworks. Internetworks means the internet of the internet. Okay, which basically the internet is a network of networks, or simply the internet. It is the largest network in existence on this planet. What is the purpose, or how it serves uh, our its own user? Internet is serving many purposes and is involved in many aspects of our life, Some of them are data communication and computer network, websites, email, instant messages, blogging, social media, marketing, networking, resource sharing, audio and video streaming. So those are purposes or advantages of using internet. Second category of network is network resource access. What do you mean by that? Now, in short, internet is all about sharing, and sharing is the main subject here. You learn how to access the network resources that others have shared, and you learn how to share your own resources with the network. Means, how do I share my data? Okay, if I have file to share or I have a resource to share, how other people can access my resources, and how can I access other people's resources? Okay. That will be clear in the next subject. So the configuration of computer devices on a network to define how network resources and information is shared or accessed is called the network resource access. How do I share the resources, and how to access the resources is what we call it network resource access. First type of network resource access is a client-server network. In this type, we have two different things. We have a client and we have server. So the client is the device that will request services from other device that is granted or granting the services to the first one. So the one who's requesting is called the client. The one is replying or granting the services is called the server. So you see now, who is sharing the data? The server. Okay, the server has the data to be shared or have the resources to be shared. Okay. Now, since we have one is requesting and one is responding, so that's called the client-server network. Okay. There can be one or more servers, either being client, request the server to serve requests. So the client sending the request, the server will grant this request or reply back. Server takes and process request on behalf of client and control access to network resources such as printer and other files, applications, and so forth. Example here, as you might see, this picture can depict what we are mentioning here. So we have server here and we have a client here. Those are the devices. So those are devices, those are client. So they are connected to each other. So if one of these guys is trying to access the resource, which is the printer, they are not accessing the printer directly. They have to access the printer through the server. If this person trying to get the server, he will access the server through the printer through the server. If this guy trying to access the printer again, he has to go through the server. If he has the right to do the print, okay, then he can print. So based on their right, they can access those resources or not. So that the main idea of having a client-server network. Next one is peer-to-peer. The word peer-to-peer means they are the first device and the second device are on the same level. So they don't have a client server in here. So they are the same level. They can both can request and both can respond to a request. So mainly I would say that the device at the meantime, he's a client and he is a server. He's a client if he's requesting service from other devices, and he's a server if other devices requesting services from them. As you see that they both are on the same level. Okay. All computers can be connected to each other and they reside at the same level and called peers. They have the same privileges to access the resources. As you see here, those devices are connected to each other, so they can access the other hard disk, they can access the other application, they can access printer as well. Third category of our network is the topology. The topology is the arrangement of the devices on the network, how the devices are arranged. Network topology is the physical arrangement of computer devices and communication hardwares in the network. Let's look at the first one. The first one is called bus topology. In this bus topology, we have a communication channel, which is the transmission media here, and the devices are connected to each other via this bus or via this transmission media. In this topology, bus topology may have a problem while multiple hosts sending data, because again, if this device is trying to send the data, he has to put the data on the bus. If this device also want to send the data, he has to put it on the bus. So this bus is sending data basically in one direction. So if both devices are putting data on the bus at the same time, then the data get lost because they will collide. Again, we are sending data in electronic form. It is electrical signal. So both signals at the same time, they might collide and we might lose the data. So this type of topology, it is easy to add a new device. Okay, it is hard to reconfigure the network, however, but it is very simple, straightforward to add a new device. All what we need is a communication channel, and we connect this device to the bus, and that for. However, it has a single point of failure, which is the bus. If the bus is down, then the whole network is down. Again, let's see what says in here. In case of bus topology, all devices share signal communication line or cable. Again, this is a single line. The data is sent in one direction only, and as soon it reaches the extreme end, the data will be removed from the line. So if this guy is trying to send the data, he will put the data online. When the data reach the end, there is a device at the end of the channel that's called terminator. It will take this signal and delete it. Okay, remove the signal from the bus. Again, the single point of failure here is the communication line. If the communication line or the bus is down, then the whole network is down. Second topology is called ring topology. With the ring topology, each device is connected to two different devices or adjacent devices, one to the right and one to the left, and at the end, all the connecting devices are forming a circular structure. In ring topology, each host computer connects to exactly two other computers, creating circular network structure. When one host tries to communicate or send messages to a host which is not adjacent to it, the data travels through all intermediate hosts to connect one more host. In the existing structure, the administrator may need only one more extra cable. Look what it says in here. I would say that each device here is connecting to two different adjacent devices, one to the left and one to the right. They all together form a circular structure. This is why we call it a ring. Now, if I'm trying to add one more device, all what I need is this device plus one extra cable only. One extra cable, because again, if I'm trying to add a device here, or I'll take this transmission media or this wire, connect it here, and these new devices need a new wire to connect here. So the device and one extra wire to add a new device. However, it is hard to reconfigure each time you add a device to this network, you have to reconfigure it, and you cannot reconfigure it while it's running, so you have to stop the network and reconfigure it. That's a problem that make it difficult and hard to build. Also, if any failure in one of the devices and or one of the transmission media, then the whole network is down. So it doesn't have one single point of failure, it has two single point of failure. So this point of failure, and this is a point of failure as well. Failure of any host result in a failure of the whole ring. Thus, every connection in the ring is a point of failure. There are methods which employ one more backup ring. So that is a more advanced subject. We're not going to go over it here. The rings or the ring make it difficult to add a new host computer while the network is running. That is why it is difficult to configure. Means if I'm trying to add a new device, it's easy. I can add it. Okay, there is no problem to add it, but we have to reconfigure it, and therefore we have to stop the whole network, then reconfigure it, then run it again. This type of network is rarely used nowadays because it is fault tolerance was very low. Next type is star topology. The star topology is the, let's put it this way, it is the simplest type of network to build. All hosts in star topology are connected to a central device called hub or switch. And as you see here, this is the hub or the switch, and those devices are connected to each other. Is there a difference between the hub and the switch? Yes, there is a difference between hub and the switch. The hub actually is receiving data from the sender and send the data it received to every other device that's connected to the hub. Okay, and therefore we can add extra money, not that much, to switch or to replace the hub with a switch. The switch basically take the data that is received and direct it only to the intended receiver. So he wants to broadcast the message all over the network, and that definitely will save money and save time. Every communication between hosts take place through only hub or the switch. So all the communication must go through this central point. As in a bus topology, hub or the switch act as a single point of failure. If hub switch fails, then connectivity of all hosts to all other devices fail. Star topology is not expensive. As to connect or one more host, it is very simple. All what you need is one wire and just connect it to the host. Connect this host through the wire, by the wire to the hub. Adding a new host will not affect the network, unlike ring topology. We don't need to reconfigure mainly. Most networks use a switch instead of a hub, as I mentioned. Switches are more advanced than hub, and they provide better performance than hubs for only a small price increase. Hub send messages to all computers in the network, which is not secure in compared to switch that only send the message to the intended computer in case the message was intended for one destination only. Number 4 is called mesh topology. With the mesh topology, each device in this network is connected to all other devices. As you might see in here, this is the mesh topology. So each device here is connected to every other devices on the network. That might make it more complicated, more complex structure. However, it gives you high tolerance, high fault tolerance in case one of the devices or one of these network transmission media is failed, we still can connect to each other. Example, if I'm I'm here, I'm trying to send the data to this guy, and I can send it directly. What if there is a failure in this transmission line? I still have alternative. So this is why we say it is high tolerance, high fault tolerance uh, in this case. However, the problem is how to build it, how to configure it, and how many connections or transmission media or how many links do I need in here. So if we look in here, if I have 5 different nodes as we see in here, then what do I need? How many connection or links do I have? Is 5 times 4 divided by 2, which is 10. What if there is 6? Then 6 times 5, 30, divided by 2 is 15. 7, then 7 times 6 is 42, divided by 2 is 21, and so forth. This type of networks or topology, you won't see it in a local area network. It's very common in the wide area network or in the internet. Okay, so it will provide us high fault tolerance or flexible connectivity. The mesh topology is the most complex in terms of physical design. In this topology, each device is connected to every other device. This topology rarely found in local area network, mainly because of complexity of the cabling. Okay? Complexity of cabling. Mesh topology is expensive to install and maintain. Cables must be run from each device to every other device. The advantage you gain is high fault tolerance, and there will always be a path from source to destination. For this reason, it's often used in WAN area network with communication device called router. The word router is come from the route, means how do I what are the different routes of sending the messages? Is there an alternative route for sending a message from one point to another point? So each one of these devices might have something called routing table. If I receive a message, then I look at the destination. What is the destination of these messages? And based on my table, I can put the message through which route or the best route. Let's take a look in here between those different devices. Topology advantages and disadvantages. The bus topology, star topology, ring topology, and mesh topology. Those are the 4 different types of topology. The bus topology has advantage such as it is cheap, it is easy to install. The star topology, it is also cheap, still not expensive, very easy to install and reconfigure. We know that the bus topology, we need to reconfigure it if we add a new device. With ring topology, efficient if you want to send a message to all other computers in the network, easy to install. It's not hard to install, but hard to reconfigure. Mesh topology, main disadvantage of it is best fault tolerance, because always we have a path to send the message through. Disadvantages, with bus topology, it is difficult to reconfigure. A break in the bus disable the entire network, any single point of failure. With star topology, more expensive than the bus. So it's not expensive, it's more expensive than the bus. This is the main disadvantage of it. A ring topology, hard to reconfigure, because each time we add a new device, we have to reconfigure the network. To reconfigure it, we have to stop the whole network before we do the reconfiguration. Very expensive and low fault tolerance. In mesh topology, reconfiguration is extremely expensive and very complex. Next is network hardware and communication devices. Since we talk about networks, there is we need a communication devices. What are the communication devices? The communication devices is any type of hardware capable of transmitting data. Any device, any hardware capable of transmitting data, instruction, and information between a sending device and the receiving device is called communication device. Those communication devices could be network interface card, or we call it NIC card, switch, router, and modem. Those are the 4 different communication devices. Let's talk about them one at a time. First of all, this can depict what we just mentioned. So we have the NIC card. The NIC card exists in every computer that needs to be added to the network. Then we have a switch to connect to make a local area network. We have to have a router to be connected to different local area networks. Also, we need a modem if we are trying to connect to outside world. A NIC card allows computer to connect to a network via a cable. So if I'm trying to connect my computer to a cable, so I have to have a NIC card. The NIC card actually has a unique ID that is uniquely identify your device. It could be a wired NIC card, or could be wireless NIC card used to connect mobile computers to the network wirelessly. So this is an example of a wired, and this is an example of the wireless network NIC card. I'm sorry. Second device is the switch. As I said earlier, the switch is a device that provides a central point for cables in local area network, and it's center of a star network. It allows you to connect more than 2 computers together. So we can connect computers together as well as 2 different local area networks together. So we have one network here and one network here. Switch is connected together to connect 2 different local area networks. Also, it is allow us to connect devices and form a local area network. Number 3 is the router, or number 4 is the router. The router connects 2 or more local area networks, or WAN, or wide local area networks, wireless local area networks. Connect internal networks to the internet when connecting to a modem. Each network is segmented by IP address. Need to configure before installation, unlike switch. Switch doesn't need to be configured. However, the router needs configuration. Configuration means you identify your device so other can know who you are. So this is what we mean by configuration. So the router connects 2 or more local area networks or wireless local area networks together. Connect our local area network, internal networks, to internet when connecting to a modem. Each network is segmented by IP address. The router need to configure before installation, unlike a switch. As you see, this is the router, and we have different local area networks are connected together via the router. If we connect this to a modem, that means we can connect to the local area network. What is the purpose of the modem means here? The modem is basically stands for modulator, demodulator. Modulator, demodulator means it is this device accept the digital signal converted to analog signal and receive also analog signal from outside and converted to a digital signal for inside. We are using the phone line. The phone line is using analog signal because it is voice. Our computer is using digital signal, so we cannot directly convert or accepting analog signal into the computer, we need a device that will convert this analog signal into a digital signal, and that can be done through the modem. Also, when I'm sending something outside, then I have to convert it from digital, which is my computer understand, into analog that other people or other transmission media can carry. So the modem is converting analog to digital and digital to analog. So that's the main purpose of the modem. Modem is a device which converts the computer-generated digital signals of a computer into analog signal to enable their traveling via phone lines, therefore connecting to the internet. This is the modem. Next is the transmission media. So how the data can be transmitted, what are the devices that can transmit the data? This can be wireless transmission media or could be wired transmission media. The transmission media is the pathway that carries data in the form of signal from sending device to receiving device. Type of the transmission media, physical transmission media or wireless transmission media. In physical transmission media, we have different types: coaxial cable, twisted pair cable, and fiber optics cable. In wireless, we have infrared, satellite, and radio waves. Each one of them has advantages and disadvantages. We'll go over them now. First one is coaxial cable. The coaxial cable is the same type of cable that you are using to connect your satellite, your dish, to the receiver. Okay, that is called coaxial cable. Coaxial cable basically it's a copper wire shielded or covered with insulator, then another shielded cover, then another cover called jacket, and data transmitted with electrical pulses. The electrical pulses speed up to 10 megabyte per second, and as I said here, this is the center conductor, or it's usually copper. This is the insulation or insulating layer. Then we have a coating layer here. Then we have the fourth one, which is called the jacket. So that's basically what is the coaxial cable look like. Next one is the twisted pair. In this type of cabling, it is very common in the local area network. Usually consists of 4 pairs of copper cable twisted. So 4 pairs twisted, speed up to 100 megabytes per second. As you see, this is faster in speed than the coaxial cable. However, coaxial cable can send the message for longer distance than the twisted pair. For the reason I'm gonna just mention in a few. So the twisted pair cable is the most common type of cabling you can see in today's local area networks. A pair of wires form a circuit that can transmit data. The pairs are twisted to provide a protection against a crosstalk. What is a crosstalk? Crosstalk is the undesired signal noise generated by the electromagnetic field of the adjacent wire. Now, if we have 2 wires next to each other, each one of them has electromagnetic field. So the electromagnetic field of the first one can affect the signal traveling through the second wire. Therefore, we have a twisted pair, and those twisted pair, they are sending current through opposite direction. Therefore, the electromagnetic field of the first one will cancel the electromagnetic field of the other one. Therefore, we're trying to eliminate the crosstalk. As you see here, those are 4 different pairs of twisted pair, okay, for transmitting data. The thing is, the distance of data being transmitted here, it's less than the distance here. Speed here is larger or bigger than here. The third one is fiber optics. The fiber optics is considered the best among those three. Data is transmitted with light pulses, not electrical pulses. It is light pulses. It is basically consists of a glass or plastic standard strand fiber instead of copper cable. So it's not metal. It's not. It is actually we're using glass, and we're sending light through this glass or plastic. It is very secure. Speed up to 100 gigabyte per second, and this is how it look like. Before we go further, if we can look back, what I mean in here is what is the main differences between those two different types of twisted pair and coaxial cable. The coaxial cable are generally used for cable transmission or cable television and internet connection. Also, twisted pair cables are usually used for telephone connection. Coaxial cable support a greater cable length. Again, greater cable length. So I can use the coaxial cable, for example, for 100 meter, just an example. However, the twisted pair cannot be used for more than 20 meter, for example. The coaxial cable cannot be used for internal wiring, means through the wall. However, the twisted pair can be used for wiring through the wall, and so forth. So those are quickly different between those two different types of cabling. Fiber optics cable can generally carry more data than twisted or coaxial cable, and they are also extremely durable and easy to run. Next type is infrared. We're talking about wireless. Since we're done with the wire, now the wireless. Infrared or IR, it has a short range communication, usually around 5 meters. Example, remote control that we are using. Second type is satellite. With the satellite communication or transmission media, we have an earth station and we have a satellite. If I'm trying to connect two different earth stations together, I have to send from earth station 1 to the satellite. The satellite will receive the signal, amplifies it, and send it down to the other earth-based station. Because of the distance here, there is a slight delay of sending the messages. So in the satellite, a space station that receives microwave signals from an earth-based station amplifies it and broadcasts the signal over the wide area. We use it to send data to remote location, but it is not that fast as it needs to go to space before bouncing back to Earth. As you see here, this is the Earth station. We send the data to the satellite. The satellite station receives the signal, amplifies it, and send it back. So he said that there is some delay between sending and receiving. Actually, we might notice that if you are listening to the radio, for example, on your car, the regular radio, and you're listening to the radio over the internet, you might see there is a difference. There is a slight time difference between those two same channel, because the one that you're using in the internet, the message is sent from the earth station to the satellite, then it comes back to the earth station, then comes back to you. This time is the difference between the two different stations. Third one is the radio wave. Bluetooth and Wi-Fi, that's the radio wave. Bluetooth is a short-range radio waves where the data rate it transfers is 100 megabyte per second within 10 meters. So the distance is 10 meters. The Wi-Fi data rate it transfers between 11 to 54 to 40 to 54 megabyte per second within 30 meters. So there is a difference in the rate and there is a difference in the distance between the Bluetooth and the Wi-Fi. Network access, network address. What do you mean by the network address? Each device in the network must have its own unique IP address, and it is a numeric number that uniquely identify each computer or device connected to a network or the internet. And this IP address are written in a dotted decimal format. There is two different versions. There is IB version 4 and the IB version 6. And definitely the IB version 4 was accommodating the network or the internet before. Then because of the rapid increase of devices in the internet, this IPv4 is not accommodating everybody, so therefore we start using the IB version 6, which is accommodating more devices on the internet. So number of devices used in IPv6 is more to accommodate everybody. Actually, this start being used, I think, 2014. If you look in here to the IP address, as we said that it's 4 different sections. So this 1, 2, 3, 4, separated by dots, and each value here is between 0 to 255. 0 to 255. With the IPv6 in here, we're still using 4.1, but however, we are using the hexa text instead of, so it is 16-bit instead of 4 bits. Okay, it is 16 bits in here. Network address. Again, there is something called host name, domain name, and DNS. The host name is the unique name of a computer connected to a network. Might reflect the purpose of computer in the network. When I say host name, for example, I say www, the World Wide Web. If I say the domain name, it is actually the domain name and the IP address, okay, are the same. One of them is a numeric and the other one is text. Okay. The domain name is basically the text version of the IP address. The DNS, the domain name server, okay, it translates the domain name into the IP address and the IP address into the domain name. So the DNS server is basically converting between the text version to the numeric version and the numeric version into text version of the domain name. And there is something called top-level domain, which is this one. This is the top-level domain. If you look in here, another thing that we need to understand is network performance. How do we decide whether the network has a good performance or it has a bad performance? First one is called latency. Latency is actually the speed. Okay? It is the time a message takes to travel from one device to another device across a network affected by the number of devices on the network measured in milliseconds. So how many devices in between, also that affect the latency. If I'm sending it directly, it is better than sending it through an intermediate devices, because those devices will take the message, process it, then send it again. That might delay the messages. Bandwidth, on the other hand, is a measure of the amount of data that the medium, or physical or wireless, can transfer over a given period of time. Means how much data, how many bytes, how many megabytes, how many gigabytes I can send over a specific period of time. El ping, another thing, is used to verify whether or not a network data packet is capable of being distributed to an address without error. The word ping is actually has a meaning. It is in English, it is a verb, means to get the attention of, or to check for the presence of another party online. Means if I'm trying to find out that a specific device is online, it is exist, and I have its own IP address, all what can I do is just ping and put that IP address. If I get a message back, means okay, this device is exist. Okay, this is what we mean by ping. Domain name system. When we talk about domain name system, there is something called top-level domain, as we mentioned when we say about the IP address and the domain name and the host name. Top-level domain, initially, all the addresses was .com. However, with the rapid increase of the websites on the internet, then we have to accommodate everybody. They came up with the top-level domain. .com means this is commercial. .net, it is network. .org, it is organization or non-profit organization. .edu, it is educational, international, government, and so forth. So this is what we call it, the top-level domain. This top-level domain also can be more specific by adding the country, which is .edu.sa, means it is educational within a specific country. And as you see here, .au Australia, .br Brazil, .sr it is Saudi Arabia, .uk United Kingdom, and so forth. Network security is very important subject. We have to make sure that the data we are sending and receiving, it is secured, and nobody that is not authorized can access our network as well. So we have to verify that the data we send and the data we receive and the user who accessing our data are allowed to do so. So first, network security is called firewall. A firewall is a machine, a device, hardware, and a software that serves as a special gateway to a network. It protects our network from any inappropriate access. So it will prevent people who are not authorized to access our data. Also, it will not allow inappropriate data to access our network, and does not allow people to send data that they are not allowed to. That, in another word, it filters the network traffic that comes in, check the validity of the messages as much as possible, and perhaps denying some messages altogether. So it will look at the data that comes to our network based on a certain policy. Do we accept this data or not? Also, if I'm trying to send the data outside, am I allowed to do so or not? For example, if I have a classified data in my organization, I will prevent my users from sending files outside the network. Okay? And that can be done through the firewall. Also, I'll prevent anybody who's not authorized to access the network by blocking them through the firewall. So it also, as I said, enforces an organization's access control policy. As you see, this is the firewall. It is a hardware and a software installed on this device. And my local area network, I can connect to the outside world through the firewall, and anybody from outside can connect with me through this firewall. So this firewall will filter traffic comes in and going out of my network. Computer network advantages. There are several advantages of the computer network. First of all, connectivity and communication. I can connect with other devices, other people, and I can communicate, send and receiving messages. I can share data. I can share hardware. I can access the internet. Also, I can do internet sharing. I can do data security and management, entertainment, watching videos, watching movies, listening to radios, live streaming, and so forth. Uh, Applications that you can see on network, computer network applications. You can see email application that allow you to send and receive emails, can access the World Wide Web application like internet. I can buy and sell products. I can do news group, internet telephony using voice over IP applications to make phone calls, do video conferencing, sending, receiving instant messages, and internet radios. Those are the main applications. Definitely there are more applications, but those are the very common one that you might see. Thank you very much. This is the last slide for today. Please, after watching this, make up your comments and be ready for questions for the live session with your instructor. Thank you very much and have a nice day.